Section 3.3, Examples 6 and 7. So here we have, once again, the product rule, quotient rule, and power rule. Now we're going to be working sort of backwards in example 6 and 7. We're going to be, instead of expanding, we're going to be condensing. In example 6, we're asked to write each expression as a single logarithm. So the log of 25 plus the log of 4, I see addition, which should signal you that we're going to be using the product rule. This equals the log of 25 times 4, and that's the log of 100. Now we can actually simplify this a little further. Remember, if you don't see the base, it's understood to be base 10. And you can evaluate the log of 100 on your calculator, or it's probably a good idea to just go ahead and memorize that this equals 2. Okay, next, log of the quantity 7x plus 6 minus the log of x. This indicates to me that I'm going to be using the quotient rule. So this equals log of the quantity 7x plus 6 over x. And I really didn't need those parentheses there, but I just put them in for fun. Okay, in the third part of example 6, I notice this expression starts with 2 times the natural log of x. So you should realize here you're going to be using the power rule. So that can be rewritten as natural log of x to the second power. We also see the power rule being used in the next portion. So that will equal, let's see, plus the natural log of x plus 5 raised to the 1/3 power. But we're not quite done. This indicates to me that the product rule has been used. So now we say this equals the natural log of x squared times the quantity x plus 5 raised to the 1/3 power. Now, we don't want to leave this in exponential form here. We want to put that back in radical form. So we say finally this equals the natural log of x squared times the cube root of x plus 5. And now for the change of base property, which states for any logarithmic bases a and b and any positive number m, the log base b of m is equal to log base a of m over log base a of b. So in other words, we want to rewrite these in the same base. See, these are both base a. Okay. And here we have the change of base property where we introduce common and natural logs. So for common logarithms, log base b of m will equal the log of m over the log of b. And using natural logarithms, log base b of m equals the natural log of m over the natural log of b. So in example 7, we're asked to use, in this first part, common logarithms to evaluate log base 7 of 2,506. So check your rule. Okay, that says we may rewrite this as the log of 2,506 over the log of 7. And this you will need your calculator for. And that's going to equal about, let's round to the hundredths place, 4.02. The second part of example 7 asks us to use natural logs to evaluate the log base 7, 2,506. So that equals the natural log 2,506 over the natural log of 7. You will once again need your calculator for this. And let's round to the hundredths place again. You should get about 4.02.